Hello, we're going to be looking at an arithmetic series. An arithmetic series and a sequence is two different things because last time we discussed about an arithmetic sequence where we just showed an arithmetic sequence. So what is a series? As a matter of fact, so a series is just addition of numbers in a certain pattern. It's still an arithmetic one because there's still a difference, which is 2, and that difference is common for all values. So you can see that if we were to add all the terms of this sequence here ends at 7, so if we were to add all of them, we will have 1 plus 3, which is 4, 4 plus 5, which is 9, 9 plus 7, which is equals to 16. So that will result in 16. So it means that the sum or the sum of all the terms in this sequence is 16. But then how would we find the sum of the 100 terms? What if we were to continue with this pattern and say plus 9 and continue until 100? What formula would we use to find the sum of the 100 terms? Therefore, we are going to jump into the sum of an arithmetic sequence. We say Sn is equals to n over 2 multiplied by 2a plus n minus 1 multiplied by d. So this is the formula which you can use to be able to find the terms or the sum of the terms in a sequence, depending on how many terms you have got. So what do you plug in here? Here you plug in your number of terms. How many terms have you got in the series? So this is number of terms, and then your a is your first term, your n is the number of terms as well, and then your d is your constant difference. Remember that this is an arithmetic sequence. So here let us just prove this formula to be correct by taking what we had at first. At first we had this series 1 plus 3 plus 5 plus 7, and then it gave us 16 when we manually added those things. What if we were to use this formula to try test it out if it's going to give us 16? So here we're going to say the sum of how many terms here? We can see that we have got 1 term here, 2, 3, 4. So we're having 4 terms. So that's why we say the sum of the 4 terms. So here on n, we're going to substitute that we have got 4 terms over 2 multiplied by 2 times. The first term is 1, and then n is the number of terms again, which is 4 minus 1 multiplied by a difference, which is 2. So here we have substituted everything we needed for the formula. Therefore, the sum of the first 4 terms, if you were to plug in a calculator, you must get 16 no matter what. But then let me just go it the longer way by saying 4 divided by 2, which is 2, multiplied by 2 plus this is 4 minus 1, which is equals to 3, and this is times 2, which is equals to 6. So this is 2 multiplied by 8, and then this is equals to 16. Can you see that the sum of the first 4 terms gives you 16? So here, remember that we added manually by adding all the terms because we had only 4 terms. But then if you have got up to 100 terms or a higher amount of terms, you have to use this formula. So we have got another formula or an alternative formula for this that states that Sn is equals to n over 2a plus L. What is different only here is that we're having L instead of this portion, or instead of instead of 2a here, we're now having a. Okay, what is L? L is your last term of the sequence. How do you see your last term of the sequence? You can see that here we're having this series here, and then at the end we have got a term after dotted lines. So those dotted lines tell us that there are many more terms until we reach here, which is the end. So that means that is your last term. So what if we were to deal with only this part, which we have started with in the beginning? So here we're going to substitute the number of terms to be 4 over 2, and then the first term to be 1 plus, and then your last term here, when you started, your last term was 7, so you have to add 7 here, and then you have 2 multiplied by 8, which is also equals to 16. So all those formulas can work, but then this formula is special if you have got the last term of the sequence. If you do not even try and use it. So this is how you calculate the sum of a series. So this is a sum of an arithmetic series. Stay tuned for our next video.